Okay, so I want to uh, review a little bit about how lines work because we're going to be talking about how we're going to be talking about things like linear correlation in the stats course. And so it's helpful to review a little bit about how lines work. So here we have an example. It says a group of 10 students were asked for their shoe size and height. The responses given are in the table given below. Oh, there's a typo. The responses are in the table given below, maybe is what it's supposed to say. I don't know. Um, anyway, but we have their shoe size and their height, right? So each of these ordered pairs represents an individual, right? So this individual has a shoe size of 6 and is 62 inches tall, right? Um, it says in the space below, plot the ordered pairs XY associated with the 10 subjects in this study. Use shoe size as the X value and height as the Y value. Okay, so again, each of these represents an ordered pair, right? Where this is our X coordinate and this is our Y coordinate for each of these ordered pairs. So let's go ahead and draw this. So let's think about how to scale our axes. If I look at all of my Y coordinates, it looks like the largest one is 73. And it looks like the smallest one is 62. So I need to scale my axes so that they extend from 62 all the way up to 73. My y-axis, my vertical axis needs to go from at least 62 to 73. So, okay. So we'll go 62, 63, 64, 5, 6, 7, 8, 9, 70, 71, 72, 73. Okay, something like that. And this is height. In inches. Okay. For my x-axis, I would do a similar thing. Looks like the smallest value for my x coordinates is 6. My largest one looks like it's 13. So we'll go from 6 to 13. 6, 7, 8, 9, 10, 11, 12, 13. This is shoe size. Okay, so to plot the ordered pairs, the way that we do that is we go over on this x-axis, we go over to this value, in this case 6, and then we go up to this value along the y-axis vertically up to 62. And so this ordered pair, 662, would correspond to this point right here. Okay, and 1068 we would go over to 10 and then up to 68. And then it's a little hard to do this without like a grid to work with, but that would be right about there. So I'll let you go ahead and pause the video and plot the rest of those ordered pairs, and then I will come back and show you what I've got. So go ahead and pause the video. Okay, so this is what you should end up with by the time you're done plotting all of those ordered pairs. A couple things worth pointing out is that we had several values that all had an x coordinate of 8. Now in the case of these two, the y coordinates were different, and so 864 is this point, right? And 868 is this point. So they are two different points. But then we had an 864 show up again over here. So there's no way to really indicate that. there's no, I mean, you could use different colors, I suppose, but that's not necessary, right? So we would just, you know, put that point on there once, and there's really no way to indicate that it occurs more than once. But this is the plot that you end up with. So there's a follow-up question that's asked here. Do you think there's a linear relationship between the two variables shoe size and height? So shoe size and height. Is there a linear relationship? And that may be a little bit difficult to answer. Certainly the dots don't fall perfectly on a straight line, but I do think that there's you could sort of imagine there being kind of a straight line that comes fairly close to all of those points. And so I would say that there is probably a linear relationship here. If a linear relationship seems reasonable, linear regression can be used to create a line of best fit. And it just so happens that for this data set that we plotted, the line of best fit is y equals 1.657x plus 51.97. We will talk in the stats class about how we come up with this line of best fit. But for now, let's just practice using it. So it says, using this line of best fit, predict the height of someone who has a shoe size of 12. Okay, so what would that line of best fit predict the shoe size to be? Well, we would just remember that x corresponds to the shoe size. So if the shoe size is 12, that means we're going to replace x here with this 12, okay? And we're going to say y equals 1.657 times 12 plus 51.97, right? So that's the prediction that we would make. Let's see what that comes out to. So 1.657 times 12 plus 51.97 is approximately, well, it's exactly equal to 71.854. All right, so that's our prediction. It asks us to identify the slope and the y-intercept for the line of best fit. So we'll practice this a little bit more on the next page, but looking at this line, the slope is the number that you're multiplying by x, and the y-intercept is the other number, right? So the slope here would be 1.657, and you may recall that the letter we use to represent the slope is m. So the slope is m equals 1.657. The y-intercept, the symbol that we use for the y-intercept is b, so we would say b equals 51.97. Okay, it's important for us to be able to identify these things because they both have important interpretations, okay? So you may recall that the slope of a line can be interpreted as rise over run. The rise is the change in the y values, and the run is the change in the x values. So the slope is a comparison of those two values. So here we're asked to write an interpretation of the slope of the line of best fit. So we want an interpretation of this slope. So remembering that the slope is rise over run, so the rise is the change in y, in other words, the change in height in this case, okay? So what this is saying is that for every increase in shoe size, we would expect to see an increase in height of about 1.6 or 1.7 inches. Okay, so if we increase in shoe size from a size 6 to a size 7, we would expect the height of the individual wearing that shoe size to increase by 1.7 inches approximately, right? That's what that slope means. So the interpretation would be something like that. For every increase in shoe size, we expect an increase in height of about 1.657 inches. Okay. Then it says, so one last follow-up question, I think, for this one. It says the y-intercept of a graph is the point on the graph corresponding to an x value of 0. Okay. Write an interpretation of the y-intercept of the line of best fit. Would this interpretation make sense in the real world? Okay. So let's think about that. So if the y-intercept is the point on the graph that corresponds to an x value of 0, x in this case represents shoe size. So an x value of 0 would mean that someone is wearing a shoe size of 0, which of course doesn't make sense, right? But what the y-intercept indicates is that if it were possible for somebody to wear a size 0 shoe, then we would expect them to be about 52 inches tall. Of course, that's nonsense, right? Because nobody wears a size 0 shoe. But that's the interpretation, right? So we would say, I'm just going to say, okay, here's our interpretation. If someone wears a size 0 shoe, we expect them to be about 52 inches tall. And then would this interpretation make sense? No, like clearly this doesn't make sense, since nobody can wear a size 0 shoe. Okay, but there will be scenarios in which it makes sense to interpret the y-intercept, and then there will be other scenarios like this one where it doesn't make sense. Okay, so moving forward, let's just practice identifying the slope and the y-intercept so that when called upon to do so, we can make the interpretations that we're asked to make. So again, the slope is the number that you're multiplying by x, and the y-intercept is the other number. And this is true regardless of the order in which the numbers are written. Okay, so whatever you're multiplying by x, that's your slope. So let's practice identifying the slope and the y-intercept. I'll let you pause the video, and then I'll work out my solutions. So go ahead and give the video a pause. Okay, I'm going to work out my solutions now. So again, the slope is the thing we're multiplying by x. So in the case of part A, the slope would be 1.2. The y-intercept is the other number. So in this case, the y-intercept would be 3.5. For part B, the slope is negative 3.74, and the y-intercept is 4. In the case of part C, don't be confused. The slope is not 17.7, right? Because the slope is the thing that you're multiplying by x. So it would be this 4.6, except the other thing to be careful of is that you have to take the sign that comes with the number. So the slope here is not 4.6 actually, like I said a second ago. The slope is really negative 4.6, okay? So the slope here is negative 4.6, and the y-intercept is 17.7. And so then similarly for part D, the slope is going to be 142.7, since that's what we're multiplying by x, and the y-intercept is going to be negative 3.452. Now, another thing that I want to review that isn't written in these instructions is that you can rearrange the order of these equations if you like. So if you like putting the x second instead of putting the x first, you can do that. Just remember, again, to take the sign that comes in front of the number. So in this case, if we wanted to rearrange the order, we could call this 3.5 plus 1.2x, right? And these two equations mean exactly the same thing. Here, we would say y equals a positive 4 minus a 3.74x. We take the sign that comes in front of the number, right? When we do the rearranging. Or more commonly, probably you like to write the equations this way. And so if you're given an equation that looks, say, like this, well, then you just rearrange the order in the same way. Make sure to take the sign that comes in front of the number. If we rearranged this, it would look like negative 4.6x plus 17.7. Okay, and this one would look like y equals 142.7x minus 3.452. Okay, so one last example. It says unicorn horns continue to increase in length throughout a unicorn's life. In case you didn't know, now you know. The length of a unicorn horn that is x years old is modeled by the equation y equals 1.3 plus 2.5x, where the length y is measured in millimeters. Part A asks us to predict how long a 52-year-old unicorn horn will be. So y is the length of the unicorn horn. X is how old the unicorn is. So if we want to predict how long a unicorn horn will be for a 52-year-old unicorn, we're going to replace the x with 52, since x represents how old the unicorn is. So we would say y equals 1.3 plus 2.5 times 52. Okay? So let's see what we get there. 2.5 times 52 plus 1.3 is 131.3. Oh, and that's millimeters, right? That's in millimeters. So we'd expect it to be 131.3 millimeters long. Okay, part B asks us to interpret the slope. So I'll let you pause the video and think about this. Remember the slope. First of all, the slope is the thing that we're multiplying by x. So in this case, it's the 2.5. And slope is rise over run. It's the change in y over the change in x. In this case, y is the length of the horn, and x is the age of the unicorn. So I'll let you pause the video, see if you can write down an interpretation for the slope. Okay, so here's my interpretation. I would say, since slope is rise over run, and since the rise, y, is the length of the horn, and the run, x, is the age of the unicorn, I would say this slope of 2.5 means that we would expect the unicorn's horn to increase in length by 2.5 millimeters for every year of the unicorn's life, right? So something along those lines. Okay, so every year of the unicorn's life, its horn will increase in length by 2.5 millimeters. Part C then asks us to interpret the y-intercept, and once again, I'm going to ask you to pause the video and see if you can write down an interpretation. So just remember, the y-intercept is, in this case, the y-intercept is this number. but it represents what we would get if we plugged in 0 for x, right? So think about what it would mean to plug in 0 for x in this case, and then use that to interpret the y-intercept. So go ahead and give the video a pause, and then I'll come back and write out my interpretation. Okay, so here's my interpretation, right? When a unicorn is newborn, its horn will be 1.3 millimeters long, right? Because if x is 0, that means the unicorn is 0 years old. It's brand new. It was just born, and the y-intercept is 1.3, so that's the length of its horn when it's newborn. Okay, so that's the idea there. We're going to practice with these things in the stats course. We'll be practicing interpreting slopes and y-intercepts and all of that, but hopefully that helps you identify them so that you're all up to speed with all of that information.